With the catalog up and running for the first time, you're just presented with a blank screen where you can create projects. Now, generally, you want to create a project for every sprint. That's kind of a good cadence. The idea is that within a project, you have a fixed set of ground truth, you have a fixed set of metrics, and you have a fixed baseline. And then all of your experimentation is done by modifying things in your inference system, but your evaluation system is, set in stone. And then when we move on to, say, the next sprint, we create a new project, and that becomes a new boundary. So at that point, you can update your, you may have additional ground truth, you might have new metrics, and you might have, you will have a change in your baseline. So we're going to create this project, and we're just going to call this Sprint 01. Seems like a good thing to start with. And so now we have a project called Sprint 01. And if we go into it, there's, of course, no experiments in it. And then, there's a couple different ways where you might go from here. Generally speaking, I think when you build out your evaluation system, part of that is going to be to create the experiment. But if it's not, and then you can create the experiment directly here. And so we can call this, let's say, very top K. And then a hypothesis, we believe that a proper top K value for searching will improve our retrieval metrics. And then we can create the experiment. Again, if your system pumping data into here does that for you, then great. And if not, then you can just create that here. And then you can go inside the experiment, and of course, there's nothing actually in here yet. But if you have data pumping in, then it'll look like that. I am going to fast forward ahead and just kind of show what this might look like in a real experiment. So here I have again a top K experiment. And you can see the catalog, fully more realized here. So we've got a project baseline, we've got an experiment baseline. Those are set to the same thing. You can read in the experiment documentation about why you might vary an experiment baseline, but fairly common to keep those things the same. And then we have a whole bunch of permutations. In this case, we ran 18 different permutations of experiments, and then I'm just showing the last 3 here. But really the purpose of this is just to show you how to use the catalog. So let's take from the top down and talk about what this is. So we can see our project, we can see our experiment. We can see our hypothesis when it was created. We can see what the numbers are down here, and I'll walk you through that in a second. And then we can see how statistics are calculated. There are no statistics for this, but I can show that in a minute. And then you can say what to actually show in the visualization, and then we can start to carve this up by tag data. There's also 3 options up here. So when you first create the experiment, you generally want to use the project baseline for the experiment baseline, unless you're purposefully trying to set it to something different, right? So you can put the little checkbox here to unlock the link, and then you can click the link if you want to use the experiment baseline, which this project has already done. If you ran a baseline and you're wanting to set that experiment as the baseline, then you would check this box, and that will set this whole experiment as the baseline for running other things. So generally in a project, the very first thing you're going to do is to run your baseline, in which case you'll use this option. You'll check this here to unlock the link, and then select that, and then that will set this experiment as your, experiment as your project baseline. Now for the last permutation of your experiment, the last permutation of the experiment that is set as the project baseline will be used as that baseline. But if you want to choose a different one, so instead of it being the last one, you can always go into a set, And there's an option up here at the top that says set this permutation as the experiment baseline. And then you can unlock that link and click on that. And that'll choose something other than the last permutation to be the permutation that's used for that baseline. And then finally, there's one more link here, which is to compute statistics for this experiment. I'm not going to do this just yet, but I will show this here in a bit. Okay, so I want to talk about what you're seeing here in the catalog. So down the left-hand side, you have all of your metrics. So we have a whole bunch of retrieval and some generation and some metadata and stuff like that. That's fine. You know, whatever metrics you have that you send to the catalog will come in automatically. You don't need to define any definitions or anything for these metrics, but certainly you can, and I will show that later. But really, anything that you pump into the catalog will get persisted. And then what you get by default is kind of these things that show up here, right? So you get the actual value of the metric. So that's this number here, right? And in this case, this is this actual number is a because we're looking at this on the experiment page here. What we're seeing over to the right is the number, the count here. So in this case, there were 1,404 samples for this that gave it a 1.0. There were 1,355 samples for this that gave it a 0.159. So this is, unless you've defined something different for the metric, this is generally an average. That's what it is by default of the permutations run over here, right? So that's what that is. So actual value, you can toggle on or off, but it's that first number. The standard deviation is this number here, which is it's basically like how a larger number means that this number is deviating by a lot. So if we look at this here at 0.946 and a 0.596 standard deviation, it means that this number is all over the place. It's hugely, this number varies a lot from sample to sample. Whereas a number like 0 up here means that there's no variance between the sample and the other. This number in between here is just the difference between this and the experiment baseline, right? So you can see here this is down from the experiment baseline by an actual amount of 0.30 or in this case up by 0.82. And then over here at the right, we've got either an up arrow or down arrow letting you know there was up or down, and then it's color coded for whether that's good or bad. So, you know, in the case of like retrieval accuracy, you want the number to go up, right? So the fact that it went down is bad since it's red, and then it went down by 15%. So that's, you know, a fairly significant shift downward versus this number here, the recall, which actually went up by, let's say, 10% in this case, right? So this just gives you an idea of the percentage of change, which is, you know, one of those things that you're typically going to want to look at. And yeah, that's pretty much that. Now, if we look down here, you know, there's some other. Generally, these things are all averages, but you can do other things too, right? Like in this case, this is just a sum of all the completion tokens. So there's really no point in getting an average in this case. We really just want to know what is the grand total of completion tokens. So that uses a different aggregate function. And there's a number of those that you can define. These things are costs, so they show as dollar values, you know, that sort of thing. Okay, what else do I want to show you here? Let's go ahead and show the statistics. So if we click on this and we compute statistics for this experiment, this may take just a minute here, but what we're going to get is a lot more detail on these. Okay, I truncated the video a little bit there because it took a few minutes to calculate statistics, for all 18 permutations. But now that we have the statistical information, we can talk about what this means. So the first thing is you're looking at the p-value, and if the p-value is very low, so let's say 0.5 or lower, then what you know is that it's very unlikely that this change is just due to random chance. If the number is high, then you really can't, like this case here, 0.26, then there's a very decent chance, at least, that this might just be noise. It's not necessarily a real significant number. And as it gets close to 1, I mean, when it's up at 1, you really can't distinguish anything about this from, noise. I mean, in this case, there's no deviation, so, there really isn't a way to calculate that, but down here, for instance, there's a 0.41, which, is, getting significantly away from 95% confidence that it's a real value. And then we have a confidence interval, which tells you a little bit about the range in which those numbers fall into. So like in this case, the range is all positive. So, that's, with a p of 0, we know that like this is a meaningful change for sure. It isn't just noise. And it's all of the values are falling to the positive side, that there's really no downside to the recall at all. The recall just simply got better. Versus if you look at like this retrieval, or let me see if I can find one that straddles. Yeah, I mean, a little bit to this one. You can see that the range of numbers is actually more to the negative side than the positive side. So like there's a lot of negative numbers in there, and maybe, or there's some significant negative numbers in there, and then it does actually work out positive, but that positive is a very, very small number, so there's probably just a lot more of those, but there are some that did have some regression. Anyway, it's something to look at, and again, you can toggle those off if it gets too noisy on here. Okay. A few other things I want to talk about with regards to the interface. So one up here is you can choose the number of permutations to show. So I can, for instance, show all 30 permutations all at one time, and there's a lot of data up there. Or I can show maybe just the last 2 that I want to look at. When you set it to something and then hit show last, it'll just show those last 2 permutations, right? So if we set it to 2 and we hit show last, then it'll just trim it to the last 2. But you can always just come in here and pick individual permutations to look at also, right? So that's, you can compare whatever you want. And then really cool, if you look up here at the URL line, you can see that all that data, the values we have toggled on or off, the sets that we're showing, the number of sets we're showing, all that's actually encoded in the URL. So you can copy this URL, put it in your documentation, and you don't have to, and then you can share that with people, and they don't have to set up their screen the same way. When they click on the link, they will get a screen which shows them the same thing you were looking at. A few other things to show about the interfaces. One is you're often like kind of talking about specific metrics, like maybe you want to look at recall, excuse me, and you want to maybe look at generation, I don't know, groundedness, let's say. By checking these checkboxes here, you can highlight the lines. And again, those get stored as part of your settings. or your URL, so then other people can see those same choices as well. Okay, what else do I want to show here? Tags. So tags allow you to carve up the data. So if we look here, we've got 1,360 results, okay? But maybe we only want to look at license data. And so if we trim it down to that, there's 10 results that are just related to the topic of license. And so we can see how it performs, differently here. So we have perfect recall on license information, but there may be other things too, like other topics which underperform or whatever. And so by choosing different things here, we can look at how different sets compare, and we can see if we get something different. Like let's go with another example here, like difficulty easy questions. So we can see here that our recall for this experiment is up 9% on easy questions, versus if we want to look at all the questions that are not easy, it's up 13%. So this change actually worked better for harder questions than it did for easier questions. Anyway, you can put as many check boxes up here and as many X's just by clicking it 2 times as you want up here, and you can think of all these as like being joins on these things. So like in this case, we're going to look at anything that's tagged error message exact or intent informational, but not frequency common. So you can get pretty advanced with what we're looking at for the filtering here, and then you can always apply those. Again, this gets stored as part of the URL, so changes there can follow through. All right. The next thing I want to talk about is clicking in to get more details. So if we want to look at this set, we can click on the word set here. And within here, we now go to a detail view. The ref here is your ground truth. So TQ10 is a ground truth that we've designated as TQ10. TQ103 is one we've designated as TQ103. So we can look at we can start to look at these at very specific ground truths. And now we can add metrics onto here. So if I click on metrics, this will give me the full designation of metrics. And so let's just look at recall. I can put as many metrics on here as I want. But if we look at recall, we can now see, okay, like for the TQ110 question, like the recall number is the same between the baseline and the aggregate. So, okay, there wasn't really an improvement there. But here, for TQ100 question, there actually is a uplift in the experiment we ran, right? So it went from 0% recall to 0.5% recall. So we started getting half the articles that we were intending to get. If we look down through here, like this one was actually worse, this one was better, whatever, right? So we can now start to look at individual ground truth questions and get an idea of how the performance looks for those. And if we want to take this a step further, we can actually talk about set iterations. So if I turn that on, now what we can see, well, actually in this case, every single one of the, so typically you're running iterations of your ground truth, and that's what this is showing you here. So we ran 5 iterations of TQ100 ground truth. And when we did that, in all 5 cases, we got a 0.5 retrieval. So that actually gives pretty good confidence that, okay, we actually did improve with this, whatever this change was, the top K change, that actually did improve for this ground truth. And if we look down here at some other ones, okay, this one as an example is a little bit more mixed, right? So in the baseline we averaged 0.5, And if you see here, we also have a standard deviation of 0.0. So you know that all 5 of the iterations in the baseline were 0.5. But here you can see we have a standard deviation and we moved up to 0.8. So it is a 60% improvement. But if you look at the results, they're not consistent, right? Like in 2 of the 5 times we had no improvement in recall, and then the other times we had some improvement in recall. So, you know, it's not always, or like this one, you have a regression, right? Like one of the times actually didn't return anything. So it's not always the case that it's always better. Like this one's another good example. And so looking at those set iterations can tell you about that. And then if you want to, you can drill into the details on that. So you can see the actual output from inference by clicking on inference, or the actual output from evaluation by clicking on eval. Now I'm not going to do that here because this data isn't something I want to share on this channel necessarily, but anyway, whatever inference output you have, whatever evaluation output you have, you typically want to be able to view those within the catalog here by just clicking on that data. And then you can start to drill in and see, okay, well, why did this improve? And then, of course, if you're trying to compare that, you might also want to look at the baseline iterations. And so you can turn those on. And now we have baseline iterations here as well. So, yeah, like let's look at this as an example here. We had, you know, the baseline was 1.0 and in a lot of these cases, but in this case it was actually 0.5. You know, so we might look at that specific case and see, well, what was going on there? Did it come up with a different query to ask that wasn't as good or whatever? And then again, we can compare those versus the actual rundown here. So this is really, you can get very, very detailed information off of this set list view. And again, you still have all your tags and stuff here, so you can start to trim this down to look at just, you know, again, we'll look at, say, maybe our easy questions. Okay, so if you see here, this number changed. So there's 68 easy questions, and now we can, you know, kind of see how those performed. You can also do filters on here. So in this case, I want to do retrieval, recall. We'll say where retrieval recall got better than the baseline. And all these are documented in the docs, so you can see what you can run there. But if I filter this down, okay, well, there's 10 of the 68 in which our set aggregate is better than our baseline, right? So we can find all those and look at those. Or, you know, you may want to look at where it got worse and then say, okay, well, those were, okay, well, there were no cases where it got worse, so that's good. So everything was either equal or greater than. So that's good. So then, you know, but if there were regressions in there, those might be cases you want to look at to improve the performance of the system. I said we'd come back to definitions, which, so if we look in the catalog HTTP file, which is found under the API folder, there's a whole section here down at the bottom around defining the metric definitions. It says define a new metric, but this is define a new metric definitions. So the metric definitions, for every thing that's in the catalog, for every metric that's in the catalog, you can define like parameter information around it about how that metric itself is actually calculated and works. If you don't do that, it will use an aggregate function of average, and it won't know a minimum and a maximum value, and it'll just put them in order, in alphabetical order. Now, that's all fine, but there's certain measurements that you can't calculate if we don't have the metric definition. For example, the percent of change, you know, which shows up on that main experiment page. If we don't know the minimum and the maximum value, then we don't actually know the percent of change. So like that particular measure won't show up if there's not a metric definition. So while technically you don't have to have any definitions, realistically you're going to probably want to put these in. And this is what they look like. This is just, again, the HTTP file has tons of examples. But in here you'll just have a list of all your metrics, whatever the metric name is, the minimum and the maximum value, the aggregate function, average, and there's some other examples down here. If we go down far enough, we should find some. Well, okay, like here's a count. Here's a cost. There's some other aggregate functions, but you can find those in there. The order is just a numerical value ascending, and that is the order in which to show those metrics in. And then what else here? There's a few different tags which can be put here. So like a tag of no P just means that this metric needs to be skipped for statistic calculations. Lower is better is used if so generally speaking, you want the metric, if it's higher, then that shows as green if it went up. So something like recall, if recall goes up, then the arrow is pointing up and it's green or whatever. But in the case of something like time, a lower number is probably better because it happened faster. So then you would want the green arrow pointing down instead of pointing up. So like that's also a tag. And there's other tags, and again, you can look in the documentation for what those are. But if you define all of these metrics, then you can commit those metrics just by running this command, and you'll notice that it targets a project. So because you might change your metrics with every project or every sprint or whatever, then these metric definitions just target a specific project, and then when you move to a new project, you'll just run this thing again. If nothing's changed, you just run literally the exact same thing again. If it has changed, then that's fine. Make the changes and then push it. And finally, there's one other feature that I wanted to show because there's no UI for this yet. But meaningful tags is a pretty interesting thing to look at. So you can put in and again, this is in the HTTP file, you can put in a project, an experiment, a set, and then a metric that you want to look at. And then you can exclude tags if you want to exclude. Like here I'm excluding validation because I just want to look at the training set. But if I run this, what this is going to do is this is looking at this particular set versus the baseline, and then trying to find where, for every one of the tags, because remember we've got 65 tags in this case, right? So for each one of those tags, how, in this set, how far does that tag information deviate on the metric we're looking at from the baseline? So in this case, we're looking at retrieval recall. And so for retrieval recall, for this particular tag, topic manufacturing, we have a diff value of negative 0.05 from the baseline if we just look at the items that are in that one tag. So there's 25 items in that tag, and for those, this is how much it differs from the baseline. And so if you simply multiply the number of them times the diff, you come up with what the impact to the overall score would be, right? So so in this particular case, the topic of manufacturing is dragging down our recall by a very slight amount, right? Negative 1.5 or 1.25. But that's the biggest thing that's drawing it down. So that's probably the area we would look at first, is improving our manufacturing. And then secondly, our multi-turn, because that has a negative impact. Everything else is a positive impact. But you can go to the other side of the equation and see what's having the most positive impact. Well, okay, the training set, which is basically everything we have. So that's not super meaningful. But this particular source of SME data, has the next biggest impact, or frequency common has this next biggest impact, or whatever. So this can help you rather than you having to look, to flag on and off 65 different tags to look for the things that changed the most in this experiment set versus the baseline, you can just look at this meaningful tags metric and it will tell you that. You can also do a couple of other comparisons. Rather than comparing versus the baseline, you can compare versus 0. Or you can compare against the whole experiment average. So within, there's an average for like the recall for this whole experiment set. And then if you ran this, it would tell you how much those things deviate from that average result. So which tags are better or worse just within this comparison set, not looking at the baseline, but just the average for that set itself. So anyway, a few different ways you can run this, but that's also something really helpful to look at.